Okay, so we shouldn't need a review of how to graph in polar coordinates, but just in case, just quickly, if theta equals 0, cosine theta is 1, so r equals 2. So angle 0, r equals 2, so we're out here, 2 units. Right? And if theta equals pi over 2, cosine theta is 0, so we're back here, right? So with pi over 2, we don't go anywhere, right? Now between 0 and pi over 2, the value of cosine theta reduces. It decreases in such a way that you get half a circle. Not particularly well drawn, but you get the idea. Okay? You get a semicircle. Then theta is going to go from pi over 2 to pi. Well, the cosine is going to go from 0 to -1, right? So when you get to pi, you have -1 in this direction, or -2 in this direction, which is just 2 in this direction, so you're back here. Okay? And if you're anywhere in between here, well, your angle goes out this way, but your value of r is negative, so you're coming back here, right? And you're just going to reflect this. And of course you can do symmetry tests and so forth and prove this. Okay? And you can easily prove, and did this, I'm sure, in, I said you do polar coordinate conic sections in pre-calculus. Some of that goes to calculus, like you did polar coordinates in calculus. So we've had that just recently, right? So you kind of, just somebody said, that's a circle of radius 2 and described where it is. You knew what it was, okay? But that's how you go about doing it. This is a circle of radius 2, center at the polar coordinates 1, 0. R equals 1, theta equals 0, right? Of course, that's the same as the rectangular coordinates in this case. Okay? So it's easily proven. Okay, well, the other thing I wanted to say is now, you only need theta to go from 0 to pi to get this picture, right? So if you made a mistake and went from 0 to 2 pi, you'd go around twice, and your integral would be twice as big as it ought to be. Okay? So we're going to, we want to set up an integral. Okay, we want to set up limits on the integral, right? So how would we do it? We start with 0 less than or equal to theta less than or equal to pi, because theta has constant limits, right? So then, what are the limits on r? Well, that was kind of easy, okay? So you get the area from 0 to pi, and then from 0 to 2 cosine theta of r dr d theta. Make sense? And that's a very easy integral. You're going to get an r squared over 2, so you're going to get a cosine squared theta. Okay? And the integral of cosine squared theta is not difficult. Okay? Got to use the right substitution and so forth. And you're going to end up with the area of this thing, which is just pi. Okay? It's got to be a circle of radius 1, right? But also the integral of cosine squared from 0 to pi is 1/2. You end up with pi. Okay?